Hello students, my name is Sumit Kundu. I am a BTech graduate from IIT Bombay, and today we are here on a session for thermodynamics students. All right. Now after the hard work that you've all put into your mechanics, now it is time to have some brownie points. All right. Now students, why is your thermodynamics is kind of very important from the JEE point of view. Okay. Primarily because of the fact that there is at least 3 to 4 questions coming in JEE mains, all right, from this particular topic. And to tell you the truth, the questions are much easily crackable. I mean, like आप आराम से इस questions को solve कर सकते हो as compared to any other problems, let's say taking it from rotational mechanics. Okay, guys. So here we will take up a particular section of your thermodynamics, that is how to solve questions in indicator diagrams. Okay, and that is what we are going to explore in our today's session, students. Okay, now overall you have got you must have studied in your 11th standard and also some parts in your coaching institutes in your 12th standards about the different parameters that are involved in questions in your laws of thermodynamics. Now indicator diagram primarily is a very important part of your laws of thermodynamics. Now that helps us to solve these problems using graphs. Now students, whenever there is a question on graphs coming, let me tell you, it is much easier to solve it if you know the finer elements, how to actually go and attack that particular problem. Okay, instead of doing tedious calculations and putting concepts here and there, it is much easier to solve and score from these kind of questions. So let us start right away, students, with a very important equation, that is my first law of thermodynamics. Okay, the first law of thermodynamics, and what does it state? The first law of thermodynamics, it is nothing but delta Q, whatever is the heat that you are actually supplying it to a system, students. All right. See, this equation, students, is basically nothing but it is an equation of conservation of energy. Conservation of energy. Okay, students. Now here, whatever heat you actually supply to a system, it uses it in 2 ways. Point number 1, to increase its internal energy. All right. Internal energy, I'm talking about a gas. Okay, so the internal energy is basically a measure of how much is the kinetic energy of the molecules increased. Because if you're talking about gas, the potential energy is not much because the molecules are weakly bounded to each other. All right. However, if you look at the total internal energy of a gas, it is primarily its kinetic energy. So what is going to happen when you supply heat to it? It is going to take all that heat, increase its temperature. As the temperature is going to increase, the kinetic movement of the molecules is also going to increase. They are going to get more energy. So that is where the heat utilized goes into increasing the kinetic energy of the molecules involved in the gas. Okay, so that is my first term. Okay, guys. And the second thing, it does some work. All right, some work is being done. Clear, students? So if I have a system, let's say that is a container in which some gas is present and it is being fitted with a piston. Okay, students, and I provided some heat, then what is going to happen? Eventually, you will see that this piston might rise and it might come to this particular point out here. So students, what has happened out here, that the gas inside this container, there is expansion taken place. All right, students. Now this expansion that which is taken place out here. Okay. Now in order to do this expansion, there is some work that was done by the gas. So we are going to see how to calculate the heat, the internal energy, and the work done. So whatever heat that you are supplying to a system, it is utilizing it in two ways. That is, it is increasing its internal energy and it is doing some external work. Okay. Now in the slides ahead, students, what we are going to do is we are going to calculate each one of these parameters separately under different conditions. Okay, and then we are going to go ahead in solving some of the questions based on graphs called as the indicator diagram. Okay, now going ahead, students, first thing I talked to you, it was the heat, delta Q. Okay, now students, this can be done under two conditions. If you look at it, we have got two conditions on which we will be calculating the heat. Okay, the first condition is at constant pressure. So the formula used for constant pressure is equals to NCP delta T, and Cp is the molar specific heat capacity of the gas at constant pressure. And my dear students, at constant volume, it is called as Cv. So delta Q is nothing but equals to NCV delta T. That is the heat supplied at constant volume, and this is your molar specific heat capacity at constant volume. Okay, students, so this was the first term. The second term we just discussed, it is work done, delta W. है ना दोस्तों? चलो, now what is your work done? This was the piston that I was talking to you about. There is some pressure exerted on this piston. Okay, so from that we can calculate what is the force. Force is nothing but equals to pressure into area. Very good. So total work done will be equal to what? If you see here, dW is nothing but equals to F dx. So let's say while this pressure is acting on this piston, the force exerted on it is how much? P into A. And this piston goes up by a distance dx. So the total work done is going to be F dx. Clear? Now here I can write this as P into A into dx. So students, if you observe here very carefully, what is ADX? ADX is nothing but P dV, that is a change in volume. ADX is nothing but change in volume, students. Okay guys, so the work done for that small expansion is PdV, and the total work done, if you have to find out, you use the integration from initial volume to the final volume and you will get your work done, students. Okay, now there is a very nice way of calculating the work done out here. Work done usually, okay, in a pressure volume graph, it is the area under the curve. That is, initially, if say the gas was at this point where its pressure was P1 V1, okay students, and finally it came to this particular point 2 where its pressure is P2 V2. Clear guys? Then by the law that we have seen here, integration is nothing but what? It is the area under the graph. Okay, it is the area under the graph. It defines the area under the graph, as a result of which you see here from point 1 to point 2 as it is going, my dear students, it is nothing but the area under this. Now if expansion is taking place, very simple, my delta V is what? Positive. So what does it imply? Work done delta W is equal to P delta V. So work done will also be what? Positive. Okay students, you got it? Now second thing what we are going to see here, compression. For compression, my delta V is what? Negative, my dear students. If my delta V is negative, then delta W, which is P delta V, will also be what? Negative. Okay students, so that is a very simple understanding. Work done is equals to nothing but area under the PV curve. Okay students, if it is compression, negative work. If it is expansion, positive work. That is all you have to remember. Students, this small concept that I am giving you, very little tips, you just remember this and you can solve any question on your indicator diagram, students. Okay, let's just go ahead now. Now, The third thing, the third parameter that was involved into the laws of thermodynamics, that was your internal energy, my dear students, and it is given by this particular formula. How did it come? We will discuss later. We will use it more thoroughly right now. See, delta U as such is a function of temperature. So, dosto, if temperature is going to increase, then my dear students, internal energy is also going to increase. So, it is going to be what? Positive. Delta U is going to be positive if temperature is increasing. And if the temperature decreases, then kinetic motion is going to decrease. If the kinetic motion is decreasing, my dear students, then what is going to happen? The internal energy is going to decrease. That's why it is going to be what? Negative, my dear students. All right. Because you see, the velocity is a function of temperature. So you see it out here. Velocity is a function of temperature. The temperature decreases, velocity decreases. Velocity decreases, internal energy actually decreases, students. So these are the three parameters that are there. Delta Q, delta U, and delta W. Okay. And if, like, we know how things are changing here. So we are going to see, like, one particular slide here in which all the signs are confirmed. If you are supplying heat to a system, it is taken as positive. The sign convention, students, is very important. The sign convention has to be applied very, very carefully in order to get all your questions right. Okay. Now, if delta W is what? If the work is done by the gas, the work is done by the gas, students, the piston is going to go up. क्या हो रहा है? Expansion हो रहा है. Expansion हो रहा है, मतलब delta V is what? Delta V is positive. If delta V is positive, my dear students, then work done is also going to be what? Positive, and vice versa is also true. Okay. Delta U, just now we have discussed, students, temperature increases, delta U increases. Okay. Very simple. Okay, now here we will go ahead and solve some problems, students. But before that, we need to observe certain things. Okay, yeah, when we are going through three processes, like, let's say we are at this point here, A, and we want to go to point B. We are going through three different processes. P1, this is like 1, and this is like 2, and this is like 3, my dear students. Okay, we want to calculate what is going to be delta U for each case. Okay, students, delta U is a state variable. It's being shown here. It's a state variable. It depends on the initial point and the final point. You go through any process, my dear students. Okay, if the delta U for process 1 is, let's say, some value X, then for process 2 also it is going to be X. Process 3 also, here it is written 2, my dear. I'll correct it. It is also going to be what? X. Because the initial point and the final point corresponds to the same thing. Initial point corresponds to PAVA, and the final point corresponds to PBVB. Okay, guys. So here, if the initial and the final pressure and the volume for all the three processes is the same, then I'm sure you've got it, that the internal energy change is also going to be the same. All right, students, then I think it is very, very clear that delta W is what? Area under the curve. So area under which curve is the most? It is basically under the curve 1. If you look at this, it is all this area. Okay, it is all this particular area. And if you look at under curve 2, then it is just this area, green portion. Clear, guys? So work done, if I can say, if this is W1, W1 is going to be greater than W2 is going to be greater than W3, my dear students. And since delta Q is equals to delta U plus delta W, then my dear students, delta U is same for all of them. Then Q1 will be greater than Q2 will be greater than your Q3. I hope everybody has understood this relation for the three different processes that we have actually shown out here. Okay, through process 1, process 2, and the process 3, how your delta U, delta W, and delta Q is actually changing, my dear students. Okay, चलो दोस्तों आगे बढ़ते हैं, and let's look at a few questions out here. But before that, we need to understand what are cyclic processes like. अच्छा students, cyclic process मतलब it started out here, it went into a full circle, and it ended out here. So students, at this point itself, what will be the change in internal energy? It is going to be what? Zero. Remember this point. If it starts from point A and it goes round and comes back to point B, which is nothing but the same point, remember this point, delta U is equals to what? Zero, my dear students. Okay, I say listen, now there are two more things that you need to understand. If the cycle is going in a clockwise manner, then the work done is positive. And if the cycle is covered in an anti-clockwise manner, okay, if it is anti-clockwise, my dear students, then the work done is what? Negative. We have a good point to explain that, okay, but just remember these facts and we will be able to solve, I guarantee you, we will be able to solve, you will be able to solve every question which is there on indicator diagram, students. Okay, chalo, let's go and explore some of the questions now. Now that's all we require. Now let's go ahead, let's find out under which path. If you look at it, under which path the work done is the least, ABC or AC? दोस्तों ABC कौन सा path है? A to B and then from B to C. And AC is what? Directly from A to C. Okay. Now students, isn't it very, very clear out here that work done under AC is this area? Right, students? Isn't it? Now, this area and the second work done under ABC, that is this process, if you see, it is the work done under AB plus BC. Clear? Now, along AB, is volume changing? Volume changing is not there. Delta V is 0. So work done is also what? Along AB, 0. Now, along BC, my dear students, what is the work done? Work done is all these portions, all these area. You see this? So which area is greater, the black ink one or the red ink one? Definitely this area, if you see the area under the BC, area under your BC is greater than the area under AC. Okay, students, so it is very clear that the work done in this process is going to be the least. So this is a clear-cut application of work done is equals to area under the curve, guys. Okay, chalo, let's explore the next question. Okay, now here in the next question, what we are going to see is, now what are they saying, students? Excuse me for that. The internal energy of the gas at state B is 20. तो यार यहाँ पे UB is equals to 20 joules, students. Okay, and at state A is 10 joules. That means at this point, students, that is UA is equals to how much? 10 joules. Clear? Find the amount of heat supplied to the gas to go from A to B. Okay, to go from A to B. We are going from, students, A to B. All right. Then those two, I think this question is kind of very, very simple. You have to find out the amount of heat supplied. So Q A to B is going to be equal to what? UA to B plus WA to B. First law of thermodynamics repeated again and again. Almost all the questions. Okay. Now this is what I need to calculate. UAB. Students, what is UAB? Nothing but UB minus UA. Acha. Students, what is the work done in the process A to B? 0. Because why? Delta V is equals to what? 0 in this particular case. So what is the heat supplied? UB minus UA. What is UB? 20. And what is UA? 10. So those two answer वैसे ही आ गया. That is equals to 10 joules, students. That simple are the questions on your indicator diagram. Okay, some of the very, very basic questions that we are actually seeing here, students. Okay, chalo yaar, let's look at the next one. Now, next one, students, what I think, you have learned this particular style for each process, how to apply the first law of thermodynamics. Do one thing, take it as a homework. And students, my phone number is 8 30880745. This is my WhatsApp number, students. Okay, do one thing. Solve this question, send it to me in my WhatsApp. Let me see how well have you learned this concept. Trust me, it will give me maximum pleasure to see as many returns as possible. And then I'm going to teach you much higher tricks, okay, in order to solve questions in indicator diagram. This is a very simple question based on totally theory. Okay, guys, I'll take few more questions, okay, and show to you how minutely, if you analyze the question, you will be able to solve it. And just based on the theory that we have learned. Okay, let us take the next question. Take this question. This has appeared in some comparative examination in the previous year, students. They have asked us what is the work done. Okay, they have. I am not reading out the question to you out here. See, they have only said that BC is a isothermal process. It is going under a cyclic process. This entire process, and BC is a isothermal. So as we go from B to C, it is an isothermal process. And they have asked us what is the work done by the gas during one complete cycle. So they are asking us students what is the work done. यार कर लेंगे ये? We could have done it. We could have done it very easily. We have just learned work done in a cyclic process is nothing but the area enclosed by the cycle. So what is the cycle out here? Cycle is like, going from A to B to C. So it is the area enclosed by the ABC region. But यहाँ पे एक challenge है. What is the challenge, students? The challenge out here is this is not a perfect triangle. यार ये triangle तो नहीं है. This is not a perfect triangle. But what I can observe out here is, my dear students, that this length, if this was a triangle by connecting these dots out here, okay, then how much would have been this thing? 300 kilopascal, right? And how much would be this? This is 2. But I don't know anything about this. This is unknown to me, students. What is the volume out here? That is in meter cube, but I don't know what is the value out here, students. What am I going to do? See, they have said BC is an isothermal process. Now, for any isothermal process, students, focus here, focus. For any isothermal process, my temperature, delta T is equals to 0. So there is no change in temperature. What does it mean? It will obey Boyle's law. P1 V1 is equals to P2 V2. So apply it between point B and point C. So 200 into the volume here is equals to 500 into 2, because that is the volume and that is the pressure and the volume at these points. Clear, students? So what is this going to be? V is going to be what? 5 meter cube. Got it, students? That is the smartness that you will have to show out here. Okay, so what is the value of here? It is 5. So this length from here to here is 3 units. So दोस्तों ये पूरा जो area होगा, this area, how much is it going to be? It is nothing but half base into height. Half base is how much? 3. Height is how much? 300. So students, if you solve this, you will get 450 units. So 450 kilojoules is the work of this triangle. Now students, do you observe one thing? That ये जो enclosed region है by the curve out here from B to C, it is just this much area. Students, this area has to be less than 450. And less than 450, what do we have? We have got 300. Now there is plus 300 and there is minus 300. Which one will you choose? Now see here. This graph, if you see carefully, is going in which direction? It is clockwise or anti-clockwise? It is anti-clockwise, students. And just some time back, you have seen that if the cycle is anti-clockwise, the work done is going to be what? Negative. So this is what is my right answer. I hope you have understood how smartly we can solve the question based on the indicator diagram as we have seen in this question out here. Okay, chalo guys, let's take another problem and you will see that this gets even simpler. Acha. Chalo. Now here I've got another question. This is again an indicator diagram. This is a PV curve, pressure, volume graph. All right, and this is a cyclic process. Starts from point A, goes to point 2, point 3, and then point A. 1 again. 1 to 2, students, is a isothermal process. It is a isothermal process. And then 2 to 3 is what? Very good. 2 to 3 is called as a isochoric. It is a isochoric process. And 3 to 1 back is called as a adiabatic process. Adiabatic process. Right, students? Okay, please excuse me for a second. All right, students. Now, here as we see this, they are telling us that the entire work done in the cyclic process is 10 joules. So all the area under this curve is what? 10 joules, students. Okay. Now, the internal energy decreases by 20 joules in the isochoric process. Chalo, firstly, let me describe to you the premise of the question, and then I'll tell you what is the solution. So as we go from 2 to 3, your U from 2 to 3, let me just make a correction here. Students, let me take a pen which is like, not so wide so that I can easily show you. U from 2 to 3, students, it decreases. So it is minus 20 joules here. Okay, it's in the isochoric process. Then delta W total in the cycle. What is it? Clockwise process. So plus 10. So it is plus 10 joules. Clear, guys? And the final thing they are asking us here, the work done by the gas in the adiabatic process, that means work done adiabatic 3 to 2 is what? Minus 20 joules. So they are asking us what is the heat added to the system in the isothermal process. So they are asking us Q from 1 to 2, what will be its value? Okay, students, chalo, how are we going to do this problem? Any idea? Any tips? Simple. Students, tell me for a cyclic process, what is delta U? Very good. It is equals to what? 0. For a cyclic process, okay, delta U is equals to what? 0. Then delta Q will be equals to what? Delta W, which means for the entire cycle, I can say this, delta W for the entire cycle, and delta U, this is for the entire cycle. Clear, students? Now here, what it means, delta Q for the entire cycle is delta W for the entire cycle. Now delta W for the entire cycle is given to us, students. What is this? 10 joules. And what is delta Q for the entire cycle? Delta Q12 plus Q23 plus Q31 is equal to the delta W for the entire cycle. That is how much? 10 joules, students. What do we have to find out? Guys, you are aware of it. This is what I need to find out. Q23. अच्छा, 2-3 में देखिए, as we go from 2 to 3, what is work done in 2 to 3 process? 0. Why? Delta V is equals to 0. Isochoric process है. Absolutely correct, students. Then what do we get? Q23 is equal to U23. And how much is that? This is nothing but minus 20. Achha. Now work done by the gas in 3 to 2. Yeah, this is an adiabatic process. Clear? Now here in the adiabatic process, 3 to 2 doesn't even matter to me. Yeah, plus work done in 3 to 1, it is an adiabatic process. Heat supplied is 0. So Q12, my dear students, is nothing but equals to what? 10, which will give me Q12 is nothing but equals to how much? 30 joules, students. See that how simple this question is. Okay, this question, students, had appeared for previous year's KVPY examination. Okay, and let me tell you, just on the very basics that we have learned today, you will be able to do all these questions. Clear? चलो और एक questions लेते हैं, और एक question लेते हैं, and students, let me tell you, this particular question which we have here, okay, and the likes of the same we are going to discuss in our modular course, wherein we are going to learn those finer elements या फिर the shortcut tricks in order to solve all these questions. Clear? Now here I'm going to give you a hint and you are going to solve it on your own, and in order to know the perfect answer, I really welcome you to join our session or the modular course on the indicator diagram, students. Okay, now see here, what is this? this is basically nothing but, this is a graph, okay, wherein I have got a cyclic process here, students. Very simple. On the y-axis, it's an indicator diagram, pressure volume वाला graph है, ठीक है. This is in ATM and this is in liter. Okay. Now they have not asked us what is the work done. What is the work done is nothing but the area under this graph. ये तो पूछा ही नहीं इन्होंने. They have asked us what is the maximum temperature. So that is a tricky part. Okay. Maximum temperature attained. अपने को ये पता है PV equals to nRT, ideal gas equation. Right, students? This is my ideal gas equation. Acha, let us assume it is one mole of gas is being considered out here. Okay, so what is temperature going to be like? PV by R. Right, students? If we are considering 1 mole of gas, then temperature can be given as PV by R. Acha, chalo, ek kaam karte hain. This entire thing, let me redraw once again. Okay, as I have redrawn this entire thing here, what do I see here? चलो इसको और भी अच्छे से ड्रॉ कर लेते हैं. Alright, students, let me take another one and draw it here. Clear? Let me go to the basic mode here, and this is what, 4 units, this is 6 units, and this is 2 units. Similarly, if you look at it, 2 units, students focus here, 4 units, and if you see here, this is 6 units. What is the radius of this graph? This is nothing but 6 minus 4, that is 2. So this is going to be what? 2. As I am going from here to this point here, acha, students tell me, what is the pressure here? 6. What is the volume here? 4. Okay. Students, what is going to be the temperature out here? 24 upon R. Acha, what is going to be the temperature here? Pressure is 4. Volume is 6. So if you calculate the temperature here, this is again going to be 24 upon R. Students, here also the temperature is 24 upon R. Here also the temperature is 24 upon R. Okay. Students, what do we observe here? This is nothing but it is a isothermal. If I draw here a isotherm out here, notice here. If I draw an isotherm out here, एक सेकंड रुक जाओ दोस्तों. Let me take a curve and directly draw it for you. Chalo, let's skip this and let us use our pen and use it very, very slowly. So this is going to be our isothermal process here. Isothermal. Now students, any point out here is going to be same temperature, 24 upon R. Okay, so here if I'm going from point A to point B, students, the temperature is definitely going to be greater than 24 by R. Okay, now here another thing that I can consider, at any random point here, this is 2. Students, notice here, what is going to be this much unit from here to here? Say this is theta. So this is going to be what? Nothing but 2 cos theta. And this is going to be nothing but 2 sine theta. So at any orbit point at theta, I can indicate its volume and pressure as nothing but equals to what? I can indicate pressure at this point is going to be what? 4 plus 2 sine theta. This is going to be its pressure. And volume kitna ho jayega? Volume is in this direction. So that is like 4 plus 2 cos theta. 4 plus 2 cos theta. Students, so that at any orbit point here, I can write its temperature, students, as what? 4 plus 2 cos theta into 4 plus 2 sin theta upon r. Now, take a hint and take a clue from here for the entire solution on this particular question, students. Okay, join us on our modular course. I've given you enough hint and clue, and for I want to see who's the smartest one among you who's watching this show out here today. Okay, who's watching this video and who can tell me what is going to be the maximum temperature in this particular scenario. I have given you so much clue, so much hint, so much premise I have actually drawn for you guys out here. Okay, now students, let me take one last question for you. Before that, I'll give you one question for homework and one last question. Now, chalo, homework, let it be one last question out here, and then we will see you only in my modular course. Students, here a very simple question. Now, see, this is not a PV graph. क्या ग्राफ देखते देखते अपने को दिमाग में बैठ जाता है it's always going to be a PV graph, but no, it's not a PV graph. It is actually your VT graph, volume versus temperature. Now here all these are what? These are all isobars. This is one isobar, this is another isobar, this is another isobar. So these are indicating nothing but, students, isobars. As the process will go along this line, the pressure is going to remain constant at that value. We need to find out what is the relation between these pressure, students. Okay. Now, students, if you observe here very carefully, we know PV equals to what? nRT. Students, can I write V is equals to nR by P into T? Now, what do we see here? Interesting thing. Y is equals to mx. Isn't this of the same format where the slope is nothing but equals to nR by P? Clear, students? What do we see here then? Pressure is inversely proportional to the slope. Out of these three isobars, which has got the maximum slope? P3 has got the maximum slope. What does it mean? That is, my P3 will be less than, my P2 will be less than my P1. So students, which one do you think is going to be the right answer? Option B here is nothing but is my right answer. So students, these are the very basic concepts that we can use, and smartly we can look at some of the questions in order to solve practically everything in your indicator diagram. Very easy to crack 4 marks for your JEE mains. And sometimes there are not just one question, students. Remember, there could be there were years in which there were 2 questions at least from your indicator diagram. Okay, so students, gear up, and let me tell you, one of the good things that we can do from here is we have a modular course of 2 hours on thermodynamics. See, primarily in thermodynamics, the maximum stress is on kinetic theory of gases and laws of thermodynamics, and that too out there, indicator diagram. So in this 2 hours session, students, we are going to learn about the tricks of the trade of how to solve any question, any given question on your indicator diagram. Okay, so you can see the other features of this particular course by visiting the link which is given to you on the screen here, that is https://vdnt.in/thermo students, and you will be able to join and learn the tricks, and not just learn the tricks, apply it for every question, whether it is KVPY, whether it is physics Olympiad, whether it is your JEE mains or JEE advanced students. Okay, fine students, see you in my modular course. Till then, take care, good night, and bye bye.